Hello everyone. Welcome back. Let's start with a very basic but powerful idea. How do we represent lines in geometry? Imagine you're holding a ruler. If you mark two dots, A and B, and join them, you get a line segment. We'll call it AB, and its length is also written as AB. Now, if I start at point A and stretch endlessly in one direction towards B, that's a ray up with an arrow. And if I keep going both ways through A and B, we call it a line up, extending infinitely. In this chapter, to keep things simple, we won't write arrows or bars every time. Just up is enough. Context tells us if it's a line, ray, or segment. Sometimes we even use small letters like L, M, N to denote a line. Now, think about three friends standing in a queue. All three are standing along the same straight line. Mathematically, we call them collinear points. But what if the three stand in a triangular shape? That's when they are non-collinear points. In fact, every triangle is made of three non-collinear points. Because if they were collinear, no triangle would exist. So, collinearity helps us decide whether a polygon is possible or not. Next, let's talk about angles. Picture a door hinge. When you open a door, two edges meet at a hinge. That hinge is the vertex, and the edges are arms of an angle. In mathematics, an angle is formed when two rays originate from a common endpoint. We write it as angle ABC with vertex at B. Every angle has a size from 0 degrees all the way up to less than 360 degrees. Angles are everywhere, from the tilt of your head while reading, to the slope of a roof, to the rotation of a clock's hand. Now, let's classify angles. These are like categories of people in a group photo. If the angle is less than 90 degrees, it's called an acute angle. Exactly 90 degrees, that's the perfect right angle, the L shape you see in paper corners. Between 90 and 180 degrees is an obtuse angle, a wide open angle. Exactly 180 degrees is a straight angle, just like a straight line. And bigger than 180 but less than 360 degrees, we call it a reflex angle. So, every angle you can think of falls neatly into one of these 5 categories. Now, angles don't live alone, they often come in pairs. Let's meet the adjacent angles. Two angles are adjacent when they share a common vertex and a common arm, but their other arms are on opposite sides. For example, angle ABD and angle DBC share arm BD and vertex B. Now here's the key property. The bigger angle ABC equals the sum of ABD plus DBC. In symbols, angle ABC equals angle ABD plus angle DBC. But if those non-common arms also lie in a straight line, then the two adjacent angles are called a linear pair. Their sum is always 180 degrees. Yes, a perfect half-turn. Alright, let's see what happens when two roads cross each other. At the crossing point, 4 angles are formed. Now notice, the angles that are directly opposite each other are equal. These are called vertically opposite angles. For instance, in the diagram, angle AOD equals angle BOC and angle AOC equals angle BOD. That's a universal truth. Whenever two lines intersect, opposite angles are always equal. Pretty elegant, right? Let's prove this important property. Given two lines up and CD intersect at O. To prove, angle AOD equals angle BOC. Step 1. Angle AOD plus angle AOC equals 180 degrees because they form a linear pair. Step 2. Angle AOC plus angle BOC also equals 180 degrees, again, a linear pair. Now subtracting the two equations, we get angle AOD equals angle BOC. Similarly, angle AOC equals angle BOD. That's the mathematical proof. See how beautifully it comes from just the linear pair axiom? So, today we learned the foundation stones of geometry, line segments, rays, and lines, how they're denoted, collinear and non-collinear points, angles, their definition, vertex, arms, and classification, adjacent angles and linear pairs with their special property, and finally, the elegant result that vertically opposite angles are always equal. These are the building blocks on which bigger theorems of geometry are constructed. And that wraps up our session on basic terms and definitions. In the next video, we'll explore deeper relationships between angles like corresponding, alternate, and interior angles that bring even more beauty to geometry. See you there.